everyone. Today's Ed Puzzle is brought to you by yours truly, Miss Peruli. So I'm making this Ed Puzzle because I want to squish two topics into one, and I didn't want to give you two homeworks, so here we go. Alright. Properties of ionic compounds. So, just to review, we know what an ionic bond is, right? Happens between a metal and a non-metal, and the electrons are transferred, right? They're transferred, not shared. Okay. The metal will lose an electron, the non-metal will gain an electron. Okay. And just so you guys know, you don't need to write down word for word everything you see on the slides, right? For this one example, right? Ionic bonds. And metal and non-metal. Right, something like that. So I just want to let you guys know you do not have to copy word for word, just make sure you're copying the, key points here. Alright. So these are ionic compounds, remember. As we have, been doing with our math checks, everything should always equal out to 0, right? Your ionic compound should be neutral. Neutral, always equals 0. Alright, properties of ionic compounds. So, ionic compounds form crystalline structures.
These ionic compounds have very high melting points and are brittle because of their 3D giant ionic lattice structure. The strong electrostatic attractions holding the 3D lattice structure in place mean that a lot of energy is required to overcome these attractions.
Alright, here are some examples, right? You don't need to write these down. I'm just showing you some examples of ionic compounds. If you go to Museum of Natural History in the city, if, one day we can go back there, there's something called the Hall of Gems, and you will see there that something like calcium fluoride, right? You see how here it's all pretty and pink and blue and purple. If the structure is lined up in a different way, so if we go back to this slide, right, you see how it's crystalline. There's different crystal patterns that can form. They find out what the pattern is through what's called X-ray crystallography. Pretty cool. Alright, yeah, and again, you don't need to write these down. But the point is that they can make many different colored crystals depending on what order they're arranged in. Alright, properties, right? The big thing here is my high melting point and my boiling point. That's a little dark, right? High melting point, high boiling point, and the structure is very stable, right? Nice and hard. Alright, ionic compounds are soluble in water. Soluble means, and when it is soluble in water, when it dissolves, it splits up into its two ions. So if we take a look here, right, we put CaF2, calcium fluoride, and here we have our little calcium ions, and we have our little fluorine ions. Right, so here is the solid, right, this is where it's still CaF2, and then once it dissolves in the water, right, we get these, what are called aqueous ions. Okay. So, what's really cool about this is that when you dissolve an ionic compound in water, it can conduct electricity, right? So this is exactly why they say you should not put electrical appliances in the bathtub, right? Because if you have water, electricity will go through it, and you may say to yourself, but Miss Peruli, water is H2O. It's not an ionic compound. There's no ions in there. No, there's not, but the water that comes out of the faucet is not straight up pure water, right? If you take a glass of water that you get from the faucet or the sink, there will be other molecules in there aside from water. And there will be some ions in there, wherever they may come from, right? And those ions will conduct electricity and you will get electrocuted, right? If you use any electrical appliances in the bathtub, so don't do that. All right.
Most ionic compounds are soluble in water. In water, an ionic compound can dissociate into its ions. So when we dissolve sodium chloride, it will dissociate into sodium and chloride ions. These ions become stabilized in water due to the polar nature of water. As you can see, the sodium ions are stabilized by the negative dipole of water, and the chloride ions are stabilized by the positive dipoles of water. This solvation stabilizes the free-floating ions. An ionic compound dissolved in water can conduct electricity. This is another key property of ionic compounds. This is made possible due to the presence of free-floating ions.
Do the first one again.
First one.
Oh, not so bright.
Second one.
Definitely brighter.
And the third one.
Very bright.
And then gradually it goes up.
Yeah.
You will see that the light bulb lights up. Hence, this solution conducts electricity. Following on the same idea, molten ionic compounds can also conduct electricity. The lattice structure is broken at high temperatures, and so the ions become free-floating. In summary, ionic compounds have high melting points, are brittle, and can conduct electricity when dissolved in water or molten due to the presence of free-floating ions.
Metallic bonding. I'm going to tell you right now, the one big thing you need to know for metallic bonding is sea of electrons, right? That's what we have in metallic bonding. So what do I mean by that? Let's see. So we've been doing ionic bonding, which is a metal and a nonmetal. I've been telling you not to worry about nonmetal, right? That's covalent. We will get to that soon. Don't worry. Now we're going to talk about metallic bonding. And like I just said, the sea of electrons, right? The electrons are free floating, and that's what we are going to get more into right now. So that is metallic bonding, okay? Metals bonding with metals. So, metallic bonds are what hold metals together, okay? So, we've seen electrons being transferred in ionic compounds. We've said that they are not shared in an ionic compound, they are shared in a covalent compound. And here, they bring sharing to a new level, right? They're not shared between two atoms, they're just shared between everyone. It's basically a free-for-all, right? The electrons are everywhere. They're just floating around, hanging out with everybody, right? Here's an electron, it's going here, there's an electron, it's going there, here's an electron, it's going there. They're just floating around, right? Hanging out with everybody. So that's what we meant when we said sea of mobile electrons, right? Floating valence electrons, and that is what holds metals together, right? So this is a gold nugget, that's a gold ring. Gold is a metal, and it has metallic bonds. So now we will get to see what we mean by sea of electrons. And there is the electron configuration, the one that I keep telling you guys not to use, but some people insist on using it. The reason that they replaced the inside electrons with that sphere is because we are only talking about the valence electrons of the metal. Okay, so these are the valence electrons, and as you can see, they are floating freely around all of the other atoms, right? Floating freely in a sea of mobile electrons. So like I just said, they don't belong to any one particular metal ion. They just hang out with everyone, right? It's a communal electron situation. No one's like, hey, that's my electron. Nope, everyone's like, hey man, the electrons are for everyone, just share them. Right? They're just floating around. Alright, so that is what happens with the electrons there, right? Sea of electrons, mobile electrons. So what are the properties of metal? So if you think about it, right, think of gold, silver. Those are pretty much the, metals that we are familiar with in like real life. Maybe copper, right? Pennies used to be made of copper. So metals have a high melting point and a high boiling point also, like ionic compounds, right? The bonds are really strong. Those little floating electrons everywhere, they cause a very strong bond in the metal. All right, so if you're trying to melt it, the bonds are strong. So you need a lot of energy in order to break those bonds. Okay? And they are capable of conducting electricity, as you know, right? We've gone over this. Do not stick any forks or knives or spoons into the electrical socket, right? Because they conduct electricity, right? You don't want to get electrocuted. So just a little review there. Do not stick forks into electrical sockets and do not put appliances into the bathtub. Good. That's our safety lesson for today. All right. Freely flowing delocalized electrons. That's the whole deal with metallic bonding. All right, alloys. Alloy is a mixture of metals, right? So, if you have water and you put Kool-Aid in, that's a mixture, right? We go all the way back to the beginning of the year, remember? So, alloys are what happens when you mix metals together. So, steel is a metal, an alloy. Pennies are an alloy, right? Copper's too expensive. So, an alloy is a mix of two or more elements. At least one of them is a metal.